Good morning. Myself Prabharan J, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is built-in self-test from the unit 4 that is VLSI testing. From the subject name is VLSI design. Let us discuss. Yeah, built-in self-test is a design technique used in VLSI circuit to allow a system to test itself without the need of external testing equipment. Built-in self-test is widely adopted in modern systems on chip, integrated circuits, and complex digital systems to improve testability, reduce testing cost, and enable test maintenance. Yeah. Built-in self-test architecture. This is the architecture of built-in self-test. It consists of several key components designed to enable a circuit or system to test itself. These components include test pattern generator and circuit under test, response analyzer, and BIST controller. The architecture embedded with the VLSI circuit and facilitating testing without requiring external equipment. Let me discuss one by one. First one is a test pattern generator. The test pattern generator generate the test vectors or pattern that will apply to the circuit under test. It can generate either a pseudo random pattern or deterministic pattern depending on the requirement. The most common test pattern generator implementation is a linear feedback shift register, which is used to generate a pseudo-random test pattern efficiently. Other test pattern generator mechanisms include counters or ROM-based pattern generator. And second one is circuit under test. Circuit under test is the part of the circuit that needs to be tested. This can be the logic portion of a digital circuit, memory blocks, or even analog components in mixed signal circuits. During BIST operation, the TPG apply test pattern generator apply the test vector to the circuit under test, and its response are collected and analyzed. Next one is response analyzer. It captures and compresses the output responses of the circuit under test when the test vectors are applied. The most common response analyzer is a signal analyzer, which often consists of another linear feedback shift register that compresses the output into a compact signature. And control BIST controller. The built-in self-test controller orchestrate the entire testing process. It controls the operation of the TPG, coordinate the application of test pattern of the to the circuit under test, and manage the response analyzer. The controller also determine when the system enters or exits test mode, and handle switching between normal operation and BIST operation. The controller may be activated externally through input or internally through built-in logic such as timer or a control register. Test access mechanism provides interface between internal built-in self-test circuitry or external devices. In system using joint test action group or boundary scan, the test access mechanism allow external control and observation of the BIST process, facilitating debugging or system fabrication. Also, test access mechanism can also be used to initiate BIST operation or report the result of the test. And then yeah, two major tasks. First one is test pattern generation, and another one is test result compaction. And random number generator. Here we are using LFSR, generate pseudo random patterns. Period is 2 power n minus 1. Pseudo random pattern is an input vectors fault coverage done by fault simulation, that is test length is large, much faster test generation continue until fault coverage 60 to 80 percentage, then switch to ATPG. And signature analyzer perform, okay, memory based architecture, and then needs of BAST. That field test or and diagnosis not needed, expensive IATE, low hardware fault coverage, poor diagnostic resolution, time consuming in hardware, lower system test effort and better diagnosis, improve system maintenance and repair. These are the need of BAST. BIST is a powerful and flexible testing methodology in VLSI that provides self-testing capabilities to ICs and SOCs. It enables testing of logic, memory, and analog components without relying on expensive external test equipment, reducing cost and improving test coverage. BIST is crucial for ensuring reliability and functionality of complex systems, particularly in mission critical application. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.